Hey everyone, welcome to Day Driven 23. I'm really looking forward to the conference and hearing all the exciting stuff happening in the Pyth ecosystem. For those who don't know me, I'm Jayant Krishnamurthy. I'm the CTO of Douro Labs. Douro Labs is one of the core contributors to the Pyth Network. We do a lot of the software development for the protocol. And today I'm here to talk a little bit about the Pyth product line. So to tell you a little bit about what Pyth offers and also some of the exciting updates for those products. To kick things off, I would like to start with price feeds. So price feeds is all about providing developers with reliable access to the fastest, most accurate market data. So price feeds are also known for the number of price feeds supported. So Pyth has over 300 price feeds that are supported on over 40 blockchains today. And Pyth is a leading Oracle solution for these reasons, because we provide fast, accurate data, and because of the selection of the data that's provided and all the blockchains where it's available. And so today, I'm happy to announce a number of improvements to price feeds on all of these dimensions. The first thing that I want to talk about is hosted Hermes RPCs. So for those of you who are using PythNet price feeds in protocols, you will be familiar with Hermes. Hermes is a web service that basically takes the data that's generated on PythNet and the signatures generated through Wormhole and packages up that data for easy consumption in downstream protocols, right? So this is where you get your signed price payloads to upload to the blockchain. Now, Hermes is a permissionless service. This means, in theory, anybody can run an instance of this service. However, it's a little bit operationally challenging to run this. You have to run a PythNet validator. The validator is a little bit of a beast. You have to run another service. So there's some work required to run this thing. So today, the state of the world is that a lot of people actually interact with a public version of the service hosted by the Pyth Data Association, which is provided for free. However, this is not really the most reliable or long-term reasonable solution to this problem. We really want to have people have lots of different options for using Hermes. So today I'm announcing that two infrastructure providers in the space, Triton One, and P2P, have created hosted Hermes offerings. So what this means is that you can go to one of these providers and pay them to get an instance of Hermes all to yourself, just like you would pay them to get access to an RPC node for your favorite blockchain. So now, if you were running your own price service, you can get rid of the operational headache. This is a good thing for consumers because it just means that you have a lot more choice in terms of how you get access to Pyth data. Now, one thing I want to mention on this slide is the fact that this is even possible is a testament to Pyth's decentralized architecture. So unlike other oracles, with Pyth, it really is a decentralized system. There isn't a centralized entity who is controlling the price data that gets used by downstream protocols, right? Anybody can run this Hermes service, and this is a proof point that multiple people actually are running the service. So this is good for developers from the perspective of reliability and security, right? It's a decentralized system. There isn't a single point of failure. And you can also optimize the cost by choosing between different providers. The next thing I want to talk about are some core system improvements to PythNet price feeds. So these are maybe under the hood kind of improvements. These are things that maybe wouldn't be obvious to you if you just took a casual glance at Pyth, but they're a reflection of our continued dedication to kind of optimizing those really critical features of the product, right? We want accuracy, we want security, we want reliability, we want latency. All of those things are really important, and I'm happy to announce some big changes that make things better on all of those dimensions. So the first thing that I want to announce is reliable testnet data feeds. So for those of you who have developed with Pyth, something that you might have noticed is that the data that you get on test networks is not as good as the mainnet data. And the reason for this is that the testnets, like say Optimism Sepolia, used to be served by Pyth's testnet. And what this means is on Pyth testnet, we don't have the same selection of data providers. It's also the test net for developers. So if we roll out something new and it breaks something, all of our users get exposed to that. And this has been kind of a problem. It's made it hard for people to test out using Pyth data in a bunch of different situations. So today I'm happy to announce that mainnet Pyth data is now available on testnets. This means that as a developer, you get access to the same great Pyth data to test your application that you would get from mainnet. So it's going to be exactly the same environment from the data perspective, which should make it a lot easier to test your apps. The second thing I want to announce is that price feeds are 20% faster. This means 20% lower latency. So, some of our team has been looking at different sources of latency in the system. We've identified a few that are easy to remove. And basically, by removing some of them, we've gotten 20% less latency. The third thing I want to talk about is we now support up to 64 publishers per data feed. So every Pyth data feed sources its data from a number of different publishers, right? Pyth has over 80 publishers who are in the ecosystem. A subset of those publishers are active for every given feed just based on what data they can actually source. Previously, the maximum number of publishers that could be supported on a feed was 32. Now, 32 is already a large number in the scheme of oracles from the perspective of how many nodes there are servicing a feed. Most oracles have less than 32 publishers per feed. However, the number of publishers per feed is a really important variable in that it controls both the reliability of the feed and the security, right? The more publishers, the harder the feed is to manipulate. You'll have to get more parties to collaborate in order to cause an inaccurate price. And also the more reliable it is, right? The more publishers have to go down before the feed goes offline. So we've actually pushed from 32 to 64 publishers. And this will help with some of the major tokens like Bitcoin really ensure that those feeds are super, super accurate and reliable. The fourth thing I want to announce is on-chain market hours. So one of the things about Pyth that is a big advantage of this oracle over others is that Pyth has access to traditional finance assets. So because of Pyth's ecosystem of data providers, a lot of these are traditional finance firms who have access to, say, US equity prices, and they put those on the blockchain through Pyth. Now, one thing, however, about traditional finance is that those assets don't trade 24/7 like crypto assets do. They have certain market hours where the market is active and there are pricing, and there's other hours where the market is inactive and there is no pricing. And this has been kind of a source of tension for users of these traditional finance feeds for a while, because it's just hard to build a system around, knowing when the thing's supposed to be online or offline. So today I'm announcing that we have on-chain market hours for for all the feeds on Pyth. So this means that you can actually go to the blockchain and figure out, when the feed's supposed to be online and incorporate that logic into your application. So these are some of the core system improvements. They represent maybe under the hood incremental improvements to the product, but they reflect a kind of continued investment in the core features of PythNet price feeds and ensuring that they are, as good as possible. Next, I want to talk a little bit about new price feeds. So as I said at the beginning of this section, one of the things that Pyth is known for is simply the selection of price feeds that it offers on a bunch of different chains. And, this month has been no exception. I just want to talk a little bit about some of the feeds that have recently been added to the protocol. So you can see here a graph of the price feed growth over time. Pyth has added about 120 feeds in the past year, right? So this is a dramatic growth in number of feeds. And just last month, we added a number of tokens like Celestia, like Rollbit, like Akash. So there's a bunch of different tokens here that get added every month. And if you're interested in getting a token or an asset listed on Pyth, you haven't, and it's not there right now, please reach out to a member of the Pyth Data Association and they can help facilitate. The last thing I want to talk about on the price feeds front is new ecosystems. So again, Pyth is known for supporting, over 40 blockchains today. I'm happy to announce that we're supporting even more ecosystems now. So we've added Near, we've added Stacks, we've added Chili's, we've added Ronin, and a few other ecosystems here as well. So again, if there are ecosystems that are not supported by Pyth price feeds that you're interested in supporting, please reach out to a member of the Pyth Data Association and they can see what we can do. Okay, transitioning from price feeds, I want to spend a little bit of time talking about benchmarks. So benchmarks is a historical data service which is provided by the Pyth Data Association for accessing historical Pyth data. And this service actually can serve both, data for making price graphs, and it can also serve data. It can actually serve signed price data that can be used on the blockchain. So this means, for example, if you have something that settles at 8 a.m. on Friday on chain, you can use benchmarks to get the exact price update for that time and use it on the blockchain to settle your contract. I have two announcements on benchmarks that I'd like to talk about. The first one is that we have a new streamlined integration with Charting Library. So Charting Library is it's a software library created by TradingView, which makes it really easy to create skinnable candle charts like the ones I've shown here on the slide. And it used to be possible to use Pyth data with Charting Library, but the integration was a little painful. You have to run a server, you have to wrap some endpoints. It was just a little bit challenging. So today I'm announcing a new streamlined integration that makes this really a small amount of code. So this is very easy to do now. You can basically use the benchmarks API endpoints and you can create customizable color matching charting library charts for your application. The second thing I want to announce is provably unique price updates. So for applications like settlement on the blockchain, you really have a certain time in mind and you want to be able to settle a contract at a single unique price for that timestamp. And I'm happy to announce today that it is possible to get a single unique price for any timestamp through benchmarks. You can simply query the HTTP endpoint to get a signed price payload and for that time. And that signed price payload is actually provably the unique one for that time, and you can prove that on the blockchain. So the way that this works is that every Pyth price payload actually spans an interval of a start timestamp and an end timestamp. And so that interval is in the signed price payload, and it basically, it partitions the timeline into a bunch of different, non-overlapping segments, like I've shown here. And you can basically get that interval in the signed price payload, check that your time is in the interval, and that proves that you have the unique price for that time. So these unique price payloads will help with settlement type applications for anyone who needs that. Finally, I want to make an announcement of a new protocol that we are launching as part of Pyth called Entropy. Entropy is a secure random number generation protocol that allows you to generate secure random numbers on the blockchain. Randomness is one of the most common requests that we get for things that Pyth should provide. So I think it's very exciting that today I'm able to announce that we are developing a solution for this. The Entropy solution is actually live in testnet today on several different test networks. And if you're interested in a deployment, please reach out again. We would love to get some more test users. I want to talk a little bit about how Entropy works, because we have a slightly different angle on the random number protocol than other protocols that you might have seen. Most people who are developing protocols in this space are using something like a VRF or a secure enclave. And these solutions work, but they're not optimal, right? The VRF is complicated. There's some very tricky cryptography involved. Could be bugs in the implementation, hard to know. For the secure enclave, you need to trust the hardware. These secure enclaves are noticeable, they're not that secure at the end of the day. So there's some issues with these solutions. And we've thought a little bit about randomness, and we've come up with a new take on the protocol that I'd like to share with you. So Entropy is based on a two-party commit reveal protocol. And this is a well-known protocol in the cryptography space for generating a random number. And the idea is that you have two parties who don't trust each other, and together they want to generate a random number, and they want to know that it's random, even though they don't trust the other party. So the way that this protocol works is that both parties first think of a random number. That's the first step in this diagram here. They just think of a random number and they keep it a secret. Second, they both hash that random number and they commit it to, or they share it with each other. In this case, they could commit it to the blockchain. In the third step, they reveal the random number that they thought of. And the other party verifies that the revealed random number is equal to the hash of that number is equal to the commitment that they shared before. This proves that they are honest and they aren't lying about what their random number is. If the commitment is equal, they basically take the two revealed random numbers and you hash them, and that is your secure random number. Now, this is a very simple classic cryptographic protocol, but it's actually perfect for generating secure randomness on the blockchain. And what we've done with Entropy is we've taken this protocol and we've extended it in a couple of different ways to make it efficient to run on chain and also to make it really scalable so that we can support lots of different blockchains for randomness. Now, this protocol has some nice properties that I want to talk about. The first one is that it's a secure protocol. So the protocol is between these two parties, and neither one has to trust each other. So what this means is that if you are a user of, say, an Entropy-powered NFT drop, as long as you are honest, meaning you generate your own random number and you keep it a secret, you don't share it with anybody else, you can know that the result of the protocol is random. You can prove that. You don't have to trust anybody else to know that the result is random. So you can know that, for example, all your attributes on your NFT rolled randomly. So this is a really nice property to have, and it's a really nice user guarantee that Entropy-powered protocols can make. The second thing is that it's fast. So Entropy is using a similar pull model to Pythnet price feeds, which means that the communication between the two parties can actually happen over HTTP and not on the blockchain. And this actually makes things a lot simpler and faster than it would be if you had to have on-chain communication for everything. The third thing is that it's really easy to use. So integrating with Pyth Entropy takes about 6 lines of code between a smart contract and also the off-chain JavaScript or TypeScript. So the last thing about Entropy, I guess I mentioned this already, is that Entropy is live in testnet on several networks today. And so please reach out if you're interested in trying this out. We'd love to get some more test users, get some more networks where we can get some test deployments going. Okay, so that's the end of my talk. I've told you a little bit about some of the exciting developments going on across different areas of Pyth, on price feeds, on benchmarks, as well as the new protocol for Entropy for random numbers. Thank you so much for your attention, and I'm looking forward to meeting some of you at the rest of the conference.